Hello everyone. We are second year students from the AI department and we would like to demonstrate a working model that we have developed for the subject Electronics Analog Signal Processing based on the learning curriculum followed in our department. I, Anushree Datta, and along with my teammate Sohan Siddharth Prasad, worked on our project titled Battery Level Indicator using Operational Amplifier in our third semester. Our project involves the following hardware: a DSP board, an operational amplifier LM324 IC, resistors, LEDs, trim pot, 7-segment displays, and Zener diode. The circuit design consists of a voltage divider network, an op-amp configured as a comparator, and supporting components selected carefully to provide the appropriate scaling and display.
Our project aims to continuously monitor the voltage of heavy-duty batteries used in automation. As the battery voltage drops due to usage, the indicator changes to show the declining charge level. By setting a reference voltage corresponding to a low battery threshold, the circuit can alert the user when the battery reaches a critically low level, helping to avoid over-discharge, which can damage certain types of batteries. Let's talk about the principle of working. The battery level indicator operates by measuring the battery voltage and using a series of comparators to turn on LEDs or drive a 7-segment display. Each comparator is set to a different reference voltage representing specific battery levels. When the battery voltage is within a certain range, the comparator outputs trigger LEDs or 7-segment display segments indicating the battery level. The working progress. The battery is connected through a 2-pin terminal block. The battery voltage is reduced and finely tuned through the voltage divider and trim pot, then compared with the Zener reference voltage. As the battery voltage changes, it will cross the preset reference voltages at each comparator, sequentially turning on corresponding LEDs and segments on the 7-segment display. Based on the active comparator outputs, the battery level is displayed using LEDs and as a numeric value on the 7-segment display. Let's talk about the applications of this battery level indicator. Power banks and portable chargers. Battery level indicators in power banks help users monitor remaining power. Using LEDs or a numeric display allows users to know how much charge is left, ensuring they recharge the power bank before it runs out completely. Electric vehicles and e-bikes. In electric vehicles, an accurate battery level indicator is essentially useful to help the driver estimate the remaining driving range. This application could extend to e-bikes and scooters, helping riders avoid running out of power mid-ride. Home automation and IoT devices. Smart home devices or IoT systems that run on battery power, such as smart locks, thermostats, and sensors, can benefit from battery level indicators to ensure uninterrupted operation and improve device longevity with time recharges or battery replacements.